screen, of course. Share. You see my screen, right?
Yes, sir.
Okay. So the first thing is that I would recommend that you run this on Kaggle, its interface, because there the data is already available and all you need is the Jupyter notebook. So let us do it this way. We go to Kaggle. This is the the link for the data set, right? And so you can click on new notebook here, and it gives you a kernel with a pretty much empty notebook shown here, right? Now to upload this file there, if you click on this file, for some people it will download if you're not signed into Google. If you're signed into Google, it will directly go to Collaboratory. Now, in principle, you can run this on Collaboratory also, but the issue is the file then has to be put on Google Drive, etc. You'll notice that the code will run, but the file has to be put on Google Drive. So instead, what I'll do is I'll just download this, and I'll download the IPyNB, and it's going to be saved here, right? Now so I have saved it here. I will go to Kaggle. I will say open notebook, and it says drag or drop a notebook here. So here's what I'm going to do. I'm going to drag the notebook there, right? Then I click upload, and it will open that notebook. So now the notebook has been uploaded. Those of you who have a computer, a Kaggle window like this open, you can try running it. I'm going to take you step by step through the process of opening this synthetic fraud detection data set and running a decision tree classifier for it, right? So the first step is to just import a bunch of libraries that you need. OS is to just look at all the files you have access to and you can print them. Pandas is the main data analytics library for Python. Alternatively, you can use NumPy, you can use, so there are a bunch of options and they have their own advantages. We will use Pandas here. Seaborn is a data visualization package that is written on top of Matplotlib. So it will make plotting much simpler. For example, I'll show you later an example. Then sklearn is Python's default machine learning libraries. And from there, you're importing something called label encoder. I'll tell you what that does later. Train, test, split, because as I had explained in the last lecture, you don't usually train on every bit of labeled data you have. You just use a subset. So you need to usually split train and testing samples. And then decision tree classifier is the classifier itself. And this lets you, get an idea of how well you have done. So if you run this uses, sorry, I forgot to run this. So now that I have run this, all these packages are now available. And if you run it, it'll tell you this file is available. So if you now do this, it reads the data in. Because this is a big data set, it's taking a little bit of time. But now you can, once it is done, you can look at the details of the data. So the data contains now 10 columns, out of which the first one is just an index. The second one it's a specific object type. The remaining, a float 64 means it is a finite precision number, right? It is not an integer. It it is something dot something point something. So it has a precision. Int 64 means it is an integer. So if you were to look at the data, step shows. So there are 11 columns here, not 10. Type is a string class of objects. These are the amounts which are floating point, because you can have like 50 paisa transactions. So for example, you'll notice there is a 0.14, which is the reason this is float 64. So this is the name of the account from which it originates. These are account numbers. This is the old balance. We have already looked at this, and this is the data label. So one of the first things you can do is this is NA, is not a number, right? And that is to check if any of these entries are missing, if some of them have not a number values. And this will give you a summary. You can see that none of them have any entries missing. None of them are not a number. So that's good. It's easy to handle this data set. Look at the value counts. So let us do this now. You will notice that it has given you a histogram of all the values of what has been flagged as fraud. You'll notice that what is not fraud is clearly visible, but what is fraud is not visible. And how to change that is you need to change the Y scale to a log axis, right? So let us now run this again. And if it is a log scale axis, it becomes visible. So if you remember correctly, there were of the order of some, yeah. So this is the ones which not only turned out to be fraud, but were flagged as fraud from the beginning itself. If on the other hand, you do it with just is fraud, now you see that there are about 6,000 which are marked as fraud, while there are what was it? Something like 6 million? No, 8,000 which are marked as fraud, and something like 6 million which are not. Now, if you remove, for example, the log, it's again very hard to visualize because it's on a linear scale, so it's too small. So let's leave it with the log scale, because it's better to visualize that way. Right? Now, let us look at a breakdown of the features. So an advantage of using pandas to open any data set which is opened as a file is that pandas has these quick summaries for everything. So if you do type.value count and then give it a df. So cbond has these libraries like count plot, which will help you print out everything here. If on the other hand, you had to turn, for example, if you had to make a similar histogram using matplotlib from scratch, you would have to rename the axis, you would have to assign a value to each of this, because these are strings, these are not numbers. So a histogramming does not work very easily when they're strings. But Seaborn has these default labels which let you do that quite easily. So now you can see that out of the 6 million in the data sets, more than 2 million were payments, more than 500,000 were transfers, more than 2 million were cash out. These are, I guess, money that went out. More than close to 1.5 million were money coming in, etc. So we can also just do this. You can just call describe and it will give you an output which, Now, for each of the columns that we saw in the data set, what describe does is it gives you all the summary statistics. So total number of data points, which is always the same because it's a table, the mean of each column, the standard deviation of each column. So standard deviation is something that Subodh had taught you. It's the mean of x square, right? And that will give you the x minus mu the whole square. So x minus mean the whole square for each element. And then you take its mean, you get the standard deviation. This is the minimum entry within each column, the maximum entry within each column. And these are what are called quantiles. So 50% is what is called the median. It is a measure of it is the value which is at the center of all the values, and 25 and 75% are the 25th and 75th quantiles. Are you familiar with the idea of mean, median, and quantiles?
Yes, sir. I am familiar. Others, I don't know.
Okay. So in any case, these are ideas that you will end up being exposed to as we do more sessions. But the good thing is that once you open a data set as a pandas data frame, it quickly gives you a way to summarize every column in it using just a DF. Now let us actually use the label encoder. So the reason we are using the label encoder is this. We saw that df.type is actually a collection of strings, right? It is payment, transfer, cash out, and we saw that here. There are 5 types of strings. But to be able to process that in a machine learning algorithm, we have to assign each of it a number. So, for example, we could have had in this column, instead of having 0 and 1, we could have just had is not fraud, is fraud as string values. And then that would make the data set larger. But because we are using integers to represent that, the data set is much smaller to save. And the 5 types of transactions, you can assign a number to each of it. And the most straightforward way to do it is to just use a label encoder. So if you now just do this, now I have modified what is called the df.type. Let us try running this again. You'll notice that it has changed, right? Instead of the type now written, it is just numbers. It is the same plot, but the x-axis corresponds to numbers. So the label encoder is an easy feature. If you have strings instead of numbers, you can just assign numbers to them very easily using this method. And this is one of the first things that if you will start doing if you have what Modish described as ordinal data instead of cardinal data, right? If you have each type of data described by a string instead of a number, and you want to assign a number to it pretty randomly, you can use a label encoder. So let us now explore some correlations to the label. So let us now do so visually so that you can understand what these numbers are better. So now this demonstrates the covariances between all the columns within the data. So the ones that are that show 1, it means they are perfectly correlated. So every variable, every column is perfectly correlated with itself, which is why the diagonal ones are perfectly correlated. You will notice that the amount, the old balance original and the new balance original are perfectly correlated with each other, because they differ only by the amount, right? And consequently, that is the reason for the perfect correlation. The levels of correlation between others will let you know how useful these individual columns are in classifying. So now let us split the data into 80% train and 20% test. So we have done that. Now, to generate a decision tree classifier, all you need to do is just, create an object called a decision tree classifier and fit X train, Y train. This will take a little bit of a while because it has to go through 6 million entries. And great, it has now trained. It is now predicting. So we have just picked 12 random samples. Let us now do 200 maybe. So the classification report is something that the sklearn, the Python default machine learning, has as a default. Let us try running it, and it will give you a status of how well you have done things, right? So this gives you the accuracy, the macro average, the weighted average. To be honest, I'm not 100% sure of what all of these metrics are, but we are going to explore this now. So we now have a so X underscore train. This is the training subset that we picked, and because we told them to give us an 80%, 20%. So you see the test site has been specified as 0.2 because we want 20% for testing. And because we gave that, the remaining, the data has been split in such a way that out of the 6 million, only 80% are in the train sample. Let us see what is in the validation sample. You will notice that only 20% are in the validation sample, 80% are in the training sample. And so, on the other hand, Y underscore train. So Y underscore train is just the which is known as the data label. Okay. Now let us actually try quantifying how well the model is at predicting the validation. Now, K has actual and prediction. Let us do K of the issue now is that in your in the sample of let's say 100,000, we seem to have only not fraud events, and this is not surprising because, like we said, the data set is highly unbalanced, right? We have the vast majority are not fraud, but if you sample about 100,000, you'll notice that it is quite good at prediction in the sense it is. Let us now do bld.hist. So once you sample 100,000, you get of the order of 3 or 4 fraudulent predictions within. Let us do is equals to. So now you see a bunch of points where it is actual. This is the actual, and this is the prediction, and these correspond to your correctly sampled, correctly predicted cases. Whereas there is a situation where you are actually not having a fraud, but it is being classified as fraud in a large array. Let us find out what fraction of those, which of those are, how many of those there are. So to find that, you need to take the length of. So one of the things I want to tell you in any basic programming is that you have a variable, right? And you can just assign it like this. And that means the value A now becomes 5, right? If you, that is using 1 equal to sign. If you use 2 equals to signs, what it does is it doesn't assign the value, it evaluates if the statement is true. So if you now give it 6, it will tell you this is false. If A is, on the other hand, an array, then it will give you an array. So let us now try, for example, k of actual equals 1, and it gives you an array evaluating all of them to be false. If on the other hand you ask k of actual equal 0, then it gives you an array. So where array of each one by one the truth values of the conditions. So now to find what fraction have been misclassified, what you need to do is you need to find the subset of this array, right? Which is k, where the actual and the prediction are not the same. So let us find length. Okay, this counts the length of an array. This allows you to apply a cut to the array k, and within that cut we are passing the condition k of actual not equals k of prediction. If you do this, there are just 3 where they are wrong, right? So, for example, and that is why you have a precision of just 0.83. Because for 3 of them, in actual, they are not fraud, but they have been predicted to be fraud by mistake. Let us try and see how to improve that. One of the ways to try and improve that is to now remove some of the columns that you think may be causing a problem. So let us remove one of these perfectly correlated, so new balance destination. From the training data set. You can do the whole thing again. Retrain. So this is the step where your model is being trained. This is the step where the model is being validated. And you now have 8 misclassified ones. So removing a column made it worse. And that is to be expected because the more number of columns there are telling your classifier what to do, it usually performs better. right? But for example, so this is why these highly correlated data sets, New Balance, original had already been removed. Let us try now removing the original one. So these here this step is the one telling the decision tree classifier not to use any of these as things to train on, right? Let us remove the flagged now. Just train it on. See, now that we're training it exactly on. So if we here is a funny thing that happened. I gave the classifier the label column itself because I forgot to remove it from the columns that had to be dropped, and consequently it is 100% accurate. It is predicting all fraudulent transactions as fraudulent transactions, and otherwise because it was literally using that whether it is a fraud or not as a criterion to train on. If instead I remove it, let us see how well it does. Now we are going to build and train the model. This time is taking much longer to train because there are way more data points for which is fraud is 1 compared to is flagged fraud is 1, right? But it has done so. So now let us do. This is only because we're showing only 200. But let us think of this. Great. So now you see that you have both kinds of misclassifications. One is a situation where some things are actually fraudulent and have been misclassified as not fraud, and the other one is where they are not fraud but they have been misclassified as fraud. So let us take the example of the in what is it? Is this 1 million? Let's just take 1 million. So about 528 out of a million have been misclassified. Let us see how many of them are false positives and how many of them are false negatives. So len of k of 0. So do you understand what I'm doing now? I am looking for the number of entries within this array in which the actual is 0, meaning it is not a fraudulent entry, but it has been predicted to be a fraudulent entry. So by the classifier. Let us see how that works. And that is, no, wait. What's going on? $256 out of 1 million are actually not fraud, but they have been predicted as fraud. And $272 are actually fraudulent, but they have not been predicted as fraudulent. And so you know what your false probability, false positivity, and false negativity rates are by just dividing that by the total length of the array. So this gives you a performance metric of, let us now see what the classification metrics are. You can see that for a case where so it is predicting, when it is not a fraud, it is predicting that it is not a fraud with 100% accuracy, but when it is fraud, it is predicting that it is a fraud only with about 80% accuracy as expected. And so yes, these are the basic steps for training a decision tree classifier to recognize based on the variables. So these are, as I reminded you, the list of features you have got. You choose to train only on a subset of them because you don't want to, this is literally what you want to predict. You want to predict whether it is a fraudulent transaction or not by using the other data sets. Let us see now how including the new balance in the original destination, an additional feature which we had earlier removed, will improve the performance of the classifier. So we will retrain this.
Sir, we have not done that decision tree, that diagram you shown yesterday. So that is then automatically here.
Yes. So the advantage of using sklearn is that many of the complicated things that all the underlying logic of how to implement a decision tree, etc., is very like you don't need to code all of that in. You can just import this. See, this is an object that you're importing from the sklearn library, right? So you are importing a decision tree classifier from sklearn.tree, and all you need to do is give it your training data, and it will do everything. Um, and as long as your data is in a pandas frame, it does this automatically. It will take a while to do it because you have 6 million data points, and this is a computationally intensive process. But it with Python, many of machine learning is just calling some, that function which is clearly available. So
Sir,
let's now,
sir, yesterday, like though there were condition in decision tree in each branch.
sorry.
Sir, in decision tree, there were condition like k is greater than 2, k is, yesterday you were showing something in that PPT.
Yes.
So
So
that how those condition, how is that? I mean, that should be different from every different situation. So
yes, and this is the step which teaches this object what those conditions should be. We can, for example, examine now model. So once it has been trained, we can examine. Let us. One second, let me look this up. Decision. So you can do. You can visualize. The simplest way to visualize this is to now just export text, right? Have we imported tree? We need to import something additional to be able to do this. But let me just show you. So we will rerun this because this needs to be run. But once that is done, export text. So now you can just print the text underscore representation, and you see the tree is giving you all the features it is
yes,
doing.
sir.
So this is
Yes, sir. Yes.
you can use something called plot tree. So let us now import the plot tree option, right? Tree plot underscore tree. Okay, no, you don't need to import it. It is a part of tree itself. So let us now just try. Let us just try tree.plot tree model. Remove all of these options. Wow. So some of the data visualization actually is quite time intensive, as you can see. It is still running. This is because okay, this is still running. Not sure. Let me rerun this. Just 1 second. Hello? Yeah, I'll call you back later. I'm a bit busy right now. Is that okay? Sorry, that was one of my students. I had to. So, okay, visualizing a tree as a plot seems to require a lot of time, but you know, we can wait for this, or let's see. If you can, in principle, specify the total the maximum depth of a tree with like then it will simplify matters a lot more. Okay, so now we will be training a much simpler tree. So let us now try. So you see, it has only 2 layers. It's just a 2-layered tree, and it visualizing this, you get it. You can get the tree to be visualized like this. Okay, now let us give it max depth of, let us say, 5. So if you let it have a max depth of 5, you see you get 5 layers. Visualizing this tree should be a little bit more complicated, but yep, you see?
Yes, sir. Yes, sir.
So on each node, you can see, what are the criteria that, for example, here it splits based on the third feature, the second feature, the first feature, and the order of all of that is decided by. So this step where you do model.fit is where it goes through the actual data and it trains itself. Let's, for example, try giving it a three layers. This should make things the right level of visualization, and as well as so now you have 3 layers, and this should be kind of easier to visualize, hopefully. Yep, you just have 3 layers, and as you can see, at each point it is based on just 2 of the features. Each feature is referred to as x of 0, x of 2, x of 1, etc. And the criteria that lands you on each node is given by the corresponding leaves of the tree.
Sir,
yes.
Sir, ऐसा भी हो सकता है कभी कि these criteria हमारे को कभी अपनी ओर से भी चूज करने पड़े. अभी तो मैं इमेजिन नहीं कर पा रहा हूँ एक्चुअली, क्योंकि सर हमने जो हमने डिसीजन ट्री खुद से प्लॉट किए ना, वो तो अभी तो मैन्युअली करते थे, अभी थोड़ा बहुत जो क्लासेस में करते थे पहले. तो उसमें ऐसा है कि हम वेट्स असाइन करेंगे और एक वेट पे एक ब्रांच बनेगी, दूसरे पे दूसरी, तीसरे पे, वो तो हम खुद से सोच के करते थे. तो बट इन दिस केस अगर हम ऐसे करेंगे तो ये खुद से भी होता है क्या?
I didn't exactly get you are asking if we can vary these values manually.
अच्छा सर, मेरे को एग्जैक्टली आपको सिचुएशन समझाने दो सर. एक्चुअली क्या है, जैसे रिस्क है, किसी भी सिचुएशन में रिस्क हमने एनालाइज करना है, तो उसको हम ब्रांचेस में डिवाइड करते हैं. जैसे कि इस सिचुएशन में 5% प्रोबेबिलिटी है, इस सिचुएशन में 3% प्रोबेबिलिटी है. अगर ये नहीं इवेंट अकर होगा तो दूसरी सिचुएशन में 2% प्रोबेबिलिटी है, या 3% है, या 50% है. तो उस तरीके से हम एक ब्रांच बनाते हैं, एंड देन वी रीच अप टू अ सर्टेन कंक्लूजन इन द एंड कि भाई अगर ये वाले इवेंट अकर होंगे तो लास्ट में इतने % रिस्क है हमारा, सो वी शुड गो विद दिस डिसीजन और नॉट. तो उस टाइप में ये डिसीजन बनते. तो क्या इस तरह की पोजीशन भी बनती है सर इसमें कभी? क्योंकि वहां तो हम खुद से वी आर एज्यूमिंग आवर ओन, हम अपने खुद से एज्यूम कर रहे हैं, यहाँ डेटा खुद से शो कर रहा है. तो यहाँ तो ये डिफरेंस है. आई होप आई एम एबल टू एक्सप्लेन.
I'm sorry, my Hindi is not the greatest, so I may have missed some of what you said, but in this step, what is happening is the decision tree classifier is learning everything based on the distribution of your data, right? It is literally being trained by this amount of data that you're giving to it. But in principle, you can manually change each of these things in each leaf and node. So
okay, then it's fine. Okay.
if you have external information in addition to this data, you can usually add that as a column to train it. For example, you know, you can add an additional column given by df of total amount equals df of amount plus df of So now you can add this, and it has an additional column. Now, because I used there is no new information here. These are two columns the tree had access to earlier anyway. So if I give it this additional column, it's not going to do anything for the tree. But if I had, for example, given it something that depends on these columns, then its performance would increase. So if you had a reason to believe that any amount over a certain threshold has a higher risk, you can create an additional column that reflects these numbers and give it to the forest, to the decision tree. Sorry. So
yeah, then it is. Yes sir, yes sir. अगर वैसा कर सकते तो ये I mean it will be very very useful sir. क्योंकि ऐसा है ना, जैसे माना मैं उस सिचुएशन की बात कर रहा हूँ, I am talking about projects. Big projects, they carry lot of risk. They risk of cost overrun and time overrun. So if we add additional column apart from the information, like information which only people know. So if we add additional column to that in the data, and then we run this kind of model, probably we will be able to train the situation better and we will arrive at better decision.
Sure.
So
Yes.
yeah.
That's definite. I mean, yes. So most of your success in training a machine learning algorithm depends on what you call the features and how good they are at telling telling the different variables apart. For example, you'll notice that one of the strongest correlations to fraud is just the amount. So the larger amounts are likely to be fraudulent, but not necessarily. And it is a combination of all of these that instructs your tree how to learn which is likely to be fraudulent or not, and then you can ask it to classify itself to tell you how well it is performing. And you see that its precision is 1%, is 100%, but its accuracy is only 88%. So I guess we have worked through one notebook on how to train a decision tree, and this really is the best way to teach yourself how to use these things is to now just play with this. So remove one by one each of these columns in this drop step, and train different trees. visualize the trees, check how well they are performing, see if you can understand why it is performing so well, etc. You can also try and use even though this data set is explicitly meant to predict if something is fraudulent or not, you can just replace this with with your what you're trying to predict as some other column and see if it performs better. For example, you would think that the total amount plus the old balance original should give you the new balance original, right? As long as the amount is something going outward. And you can verify those intuitions by turning your y-axis into the new balance original and training your tree and seeing how well it is describing your testing data. So I would recommend all of you to take this notebook as it is and just play with it. And at each time you play with it, keep changing things so that you develop an intuition for how these things work. Because I have described to you how it works internally in the previous lecture. The only thing left to teach you is really what this step does. Like when you give it a data to train on, how does the tree learn these things? And for that, you need to actually learn some information theory, which should be for the future modules of this course. This is an introductory course, so I'm just teaching you how to use the software as a black box as it is. So do you have any questions now?
Sir, जब करेंगे, we will ask. Right now we have to, go through these.
Sure.
So next Friday.
Yeah. Feel free to ask the questions next Friday. Just play with it. What I will do now is I will try and answer Vaishali's earlier question. So let's find that.
Hello, sir.
Hello.
Hello. Hello, sir.
Yes, I can hear you.
Yes. I just posted questions also. That was question 1 regarding that stack. So I solved it using set and list.
Right. So 1 second. Let me just find your, Wait, you had asked a question somewhere here, right?
Yes. So that actually I wanted iteration method for both append and pop. Because for 40 numbers I can't append 1 by 1, no? Natural numbers are needed, so I want to get it like after 1 it should add 2, 3, 4.
Sure. So
iteration method I needed basically.
Sure.
Yeah. And that again that first method is actually, I do not know whether it is correct. For the set method is first in, first out. So the question I think doesn't belong to question 1 because it is asking about stack. So stack is not first in, first out, no?
Stack is first. A queue is first in, first out. Stack is first in.
Stack is the list, last in, first out.
Right.
And queue is first in, first out, or like DQ is also there. So actually I got confused in that. So I think that second list method is there. So 2 programs I have made there. The second one is list. Second one is list.
No, let me check if stack this object that your has. So this object that your so I don't know why you used a set to add elements to it, because as far as I know, the elements in a set are not in an order, right? This is a mathematical object called a set, right?
Mm-hmm.
But
Actually, if I am using set, then when I use pop, it is popping to that first element, not the last element. No? So that's why it is first in first out. So it is again not
okay,
applicable to stack.
so you just wanted to know how to use an iteration to pop elements from this, right?
The second list, so that list method will also, I think that is only correct. The
So
second one.
to use
Regarding question one.
to use an iteration, all you need to do is for I in range 15. Was the question one for 15 or 18 or 17 or something? I don't remember. 1 second. Let me pull up the question.
Blank stack, after that initial stack we get let's say 1 2 3, and then I'm appending. So
Yeah. So it says
initial stack is blank, and then I'm adding this one by one. Okay,
yeah. So
that is
you
append one. So, but I don't want that append one. One I don't want to write. Suppose I am writing 1 2 3, but after that I want to increase that 1 2 3 naturally. I want natural numbers from 1 to 40. No? In sets, what happened? We can use range, so it is automatically happening. That is
sure.
what use of sets. No?
Yes. So you
But
can always
here,
do
how to do iteration then? Because if I every time if I write add 1, add 2, add 3, so it will be add, or I think in list push can also go.
sure. So
Append or push. But I don't want to that push or append 1 2 3. I want that in iteration. So append I, if I do append, let's say I is some variable I equal to 1, and then I want to increase that variable every time. But that is not working with for or while loop, whatever loops are available.
yeah, but
So how to do that?
yeah, so let me just show you. So let us declare a blank stack like you have.
Hmm. Hmm.
And now for I in range 41,
Hmm.
stack dot append I. This tells it, right? So now you can just see what is in your stack. See?
Okay, it's coming.
Is this what
That
you want?
actually, okay, stack that up. So with the for it is range 41. Okay. So it is written range 41. Sorry, 1 comma 41. So it will take 1 to 40.
Yeah. Well, it
It
goes zero.
doesn't 41. It doesn't include.
But if you want to do now, it will go 1 to 40. See? So does this answer everything you wanted, or
This I wanted, and after that, how to again pop? Then again, same thing.
again what?
I mean, how to pop one by one? Like 28 numbers we have to pop, no?
Yeah. So okay, for I see those questions were not like, I mean, this was just to test your intuition on a stack and a queue. I wanted you to do it in your mind, but if you want to see your code, I mean, for
So,
stack.pop. Now let us see what is left in the stack. See?
So only 28 you have taken, that means 28 times it will, this instruction will run.
Yes.
Okay. So that's actually this, I mean, such type of help I'm not getting from whatever I searched. So that's
Sure. Don't hesitate to ask. We'll have more of these Q&A sessions, and you can ask explicitly where to. But the best way is to see. One of the things I noticed is that in your notebook that you had already written, all the ingredients for this is already there. You know how to write a loop. The issue, after a for loop, you need to do this. You need this space. If not, it will run only once. Okay, so for example, if
actually here the syntax is different. Na? Python is new to me. I know the other programming language, C, Java, etc. So that's
example, if you don't give the space, as far as I know, it will
error will come. Yes, that space is required. Okay.
So, Python, for example, if you were writing C++, you would open a bracket here and you would close a bracket here, right? But this is Python, so the same thing as opening and closing a bracket is achieved using your this intending. So, for example, you can also give print. So let's just do
print stack.
A equals.
Print K also we can do.
And what it will do is it'll print it. See, it is printing it now 28 times. Like 28 times, it's printing the value that has been popped. Great. So, you already know everything you need to, as in, you already have the tools for the same questions you asked within here. If you face too many difficulties, just, I don't know, email me or something and I'll reply.
Okay.
Or WhatsApp.
And just about the question with the second question, that MTQ, NQ, and I think DQ is also there. First 25 natural numbers. This is problem state, that 3 question 2.
Yeah, the issue is as far as I know, there is no, there is no default Python data structure which has the features of a queue implemented very easily. So you might have some.
No, I actually tried. That is DQ function is there. I tried one program, so we have to, some import DQ. That is some file named, I think, DQ. So with that, it is working. But again, I will try with that iteration. Again, I want iteration only, like this. So I will try with that.
Sure.
Fine, whatever, I will try, and I will just share the notebook so that we can check.
Yeah, if you share the notebook with me, I can help you. But this is just very, So the first 2 questions in the problem set that I shared, I wanted you to just like use intuition. I didn't really mean for you to code it up, but it's good that you coded it up and you're testing your intuition. So we had figured out how to do problem number 3, and
this is, I think 3 is bit theoretical only, no? 3, and I think 4 was remaining.
Yes.
No, 4 we have done, 3 was remaining, I guess.
Yes. So, 3, I explained how to do it using what is called the binomial distribution.
Yes. Okay, fine.
Do we have any more questions?
Sir, just I was trying to upload this, you told initially to how to upload that this in Kaggle. Can you just explain again?
Sorry, your voice is very, like it's not clear, so I didn't understand. You cannot upload the file, or
Hello. That CS20174 that you gave, na, log.csv. CSV file you gave in Kaggle. So I'm not able to upload that.
you mean this file?
Uh,
Oh,
yes, that one.
but where do you want to upload? You don't need to upload this file. This file is there on Kaggle. You
That's fine.
need to
Okay.
upload the notebook. So let me repeat the.
No. I have opened, so it. On Google Collaborator, it is opening that full Python that notebook, and
Oh, sure. So
so but
you,
not taking that CSV file. Where I'm running, let's say that setup library, then second check input data, and after third reading data. So that it is not
okay.
finding some
Let
error.
us try looking for it. Let us figure out a way to open that.
Mm-hmm.
Notebook.
Second one is also okay. Third, that reading is DF.
Okay. So the issue is that that file is there, and you need to upload here.
Yes. Up.
So let us now go to Kaggle, right? You can hit download. It's a 471 MB file.
Mm-hmm.
It is now downloading. Give it a while.
So download, and then should we unzip that file, extract that file?
Sorry?
Should we extract that file? We need to extract that file, CSV file.
You don't need to extract. So the file is there on Kaggle. If you decide to run the notebook on Kaggle, you don't need to download the file because it will find it from the server. If you want to run it,
Okay.
if you want to run it on Collaboratory, you should upload the file first, right?
Okay.
Let me just find the name of the file, archive.zip. So I should ideally. I'm now extracting it. So now the file is here, and you should upload it using this. What was the name of the file? PS underscore. We found the file. let's upload it. Okay. It's now uploading the file. This is taking too long. Anyway, now once you do this, you can run this here and it will find the file. So see, you can find the file now here. So all you now need to do is go hit. So you can now run this also on Collaboratory, but you have to change the path, see, because we just uploaded this to now the parent directory, so you don't need to point it anywhere. Hopefully, it has opened. So now, if you do df, you can open this. You can open the same data set also in Collaborate. But don't sweat this. Don't I mean, you can just run it on Kaggle, right? That's. But you can do it however you like. So yes, that is. Do you have any other questions?
No, sir.
Anyone else? So I would recommend that until we go on to module 2, Subodh will be giving 2 more sets of examples, etc., and he'll be teaching you more concepts. And then we'll have a module 2, which will just be basically teaching you how to program, open more files, make more plots, train more things. And until then, I think one of the best way to go about it is to just take this notebook and vary everything. Change everything. Change how you're training the decision tree. You type out something like decision tree classifier sklearn on Google, and you will see documentation like this, which will tell you what are the options it will take. And you can try Guinea, you can try entropy, you can try changing all of this and see how the performance of the notebook changes. Of the classifier changes. And this is by just trying a lot of things is how you learn. So that is what I have to say for today. If anyone has any further questions, please ask. Otherwise, we can stop this call.